Hello and welcome once again for another Advanced Engineering Math Day 1 example problem. This is Day 1 example problem number 3. Verify that y is a solution of the ordinary differential equation. Determine from y the particular solution satisfying the given initial condition. Sketch or graph this solution. Now this is going to be similar to the last example problem, except for now we also need to find the value for the constant c here. So we have the ordinary differential equation, y prime is equal to 0.5y. Now notice that this, as you should recognize at this point, should be easy to see, this is a first order ordinary differential equation. The second part is the solution is given by c times e to the 0.5x. So y equal to c e to the 0.5x. And the third part is we're given an initial condition where x0, this is my x0, is 2, and my y0 is also 2. Okay? Now, again, we're going to recall that y prime is equal to dy dx, so I should be able to take the derivative of this c e to the 0.5x with respect to x. And if I do that, it's fairly simple. Again, this would technically need the chain rule, but you should remember the process for exponentials that only have an x in the exponent there. Because it's fairly simple to do the derivatives of these. And what I find is that I get 0.5 c e to the 0.5x if I take the derivative of that. So that means that my y prime is equal to 0.5 c times e to the 0.5x. That was my left-hand side. I was just looking at the y prime. Now I should be able to substitute in the c e to the 0.5x for y on the right-hand side and verify that I get the same thing. And you should see that if I substitute this in, that's exactly what I get, is 0.5 c e to the 0.5x. Therefore, this is a solution to the differential equation, and it is a general solution. Now, to handle the initial condition, well, what I'm going to do is I'm going to substitute in 2 for x. So basically, I'm going to substitute in 2 for x here, and then set this whole thing equal to 2. So that means that I should have y of 2 is equal to 2, which implies that c times e to the 0.5 times 2 should be equal to 2. And that's what we're going to do down here. 2 is equal to c times e to the 0.5 times 2. 0.5 times 2 is obviously 1, so that's just c times e. So I have 2 is equal to c times e. And what this means is that c is equal to 2 divided by e. And if I graph the solution, this is what I find. When I multiply by 2 divided by e, 2 divided by e is slightly less than 1, and that's where the crossing point should be here for this exponential. So that's my solution to this differential equation. That's all that I have for this video. Hope to see you again soon.